Hey everybody, I just wanted to do a little quick summary of 5.1 and introduce what we have we call exponential functions. Basically an exponential function is when the variable is in the exponent. You know, normally up until now we've had x squared or 3x cubed, something like that, where x is the variable. An exponential function is when you have 3 to the x, and x is in the exponent or the power. Okay, so that's what an exponential function looks like. So in this section, we're basically going to work a bunch of problems, but we're doing the same thing, just one type of problem where we're solving equations that are exponential equations. And these are equations that you can actually get the base to be the same. Now remember, we have this common base property. Oh, let's see. Let me the right thing. Common base property right here. This is how we're going to work it every time. Look, we have a to the x. A lot of times I write it b to the x, but we have it listed here as a to the x. These are called the base. Okay, the number that's actually raised to the power. So in these equations, if we can get both bases on both sides to be the same, then we can set these exponents equal to each other and solve. That's how we're going to do it every time. Okay, so I'm just going to work a few examples. Let's look at the first one. This is right out of the homework. If you notice this, you have 2 to the x minus 8, and you have 1 over 8. So our goal here is to try, if we can write both sides in terms of the same base, then that's good. And every problem in this section ought to work that way. So let's look at 8. Well, we know that 8 is 2 cubed. 2 times 2 times 2. All right? So we're getting close. This is 2, actually 2 over 1. Right? And this is 1 over 2. So they're not the same base yet. So what we want to do is we want to bring 2 to the top. Okay, and let me rewrite it up here. We have 2 to the x minus 8. If I bring 2 to the top, or to the numerator, all you have to do is put a negative on the exponent. Now we have our 2's are the same. Therefore, from that rule that we're using, if we can get these to be the same, then we basically can drop those and set our exponents equal to each other. And then we're left with a basic equation to solve. So that would be negative 3 plus 8. We get 5. Okay, this is how we're going to solve all of these exponential equations for this section. Now there are going to be some where you can't get the same base. That is section 5.4, so we're not going to cover that in this section. Okay, let's look at this one, number 3, out of your homework. Notice you have that cube root. The first thing you want to do is you want to rewrite that as a power, as an exponent. So that would be the same as 5 to the 1/3. And that's raised to the x. Okay, so if you remember this back from when we had exponents, if you raise a power to a power, you can multiply them. So that would be 5 to the x times 1/3, which is x over 3. And then 125, we should be able to write that in terms of the same base. That is 5 cubed. All right, so we got it. 5 and 5 are our bases. So we can use our rule, relating the bases, we can take the exponents and set them equal and solve from there. That would give us x equals 9. Okay, if you notice, this problem has the letter e in it. So e is a number that's similar to pi. E represents approximately 2.72. It's actually a number that's used out a lot of times for exponential growth. It's used a lot out there in the scientific world, enough to where it has its own button on a calculator. But it's similar to, in the way we think of pi being 3.14, e is 2.72 approximately. So when we see e, we treat it like just a regular number. So if we're solving this one, we have e to the 4x plus 3. What's that, the 5th root of e? Okay, we want to rewrite that. That would be e to the 1/5. And once again, e is just a number, so we basically have the same bases. All right, e and e. So we have, since those are the same, we can set 4x plus 3 equal to 1/5, and then solve from there. Let's see, I'll just multiply both sides by 5, just a basic equation. You want to do that, you get 20x plus 15 equals 1. Let's subtract 15. I'm running out of room, so let's do it over here. You can divide out by 20. Here we go. And that does reduce, let's see, we can take out a 2, that would be 7 over 10. X equals -7/10. But try not to let e freak you out at all. It's just treated like a regular number. All right, let's do this one. We have 1/6 and 36. Okay, we want to get the same base. We do know that 36 is 6 squared, and we have 1/6. So let's focus around letting the base be 6. So first on the left side, I want 6 to come up to the numerator, right? And when you do that, you can. You just make it 6 to the -1. And now 6 is now 6 over 1 instead of 1/6. And then 36, we can write that as 6 squared. Okay, so when we raise a power to a power, remember we have to multiply it. So in this first one, when you multiply -1, you have to multiply it by each term. So that would be 6 to the -x plus 5. And this would be 6 to the 2x. But now we have it to the point. Our 6's are the same. Therefore, we can set our exponents equal to each other. And here we go. Now we can just solve just a nice basic equation. That we get, what, 5/3. There's my answer. And the last one I want to cover, which is like number 9 in the homework, I wanted to cover this one because we have an x squared, which means we could get 2 possible answers. So let's work this one. So we have 2, which is base over here, and there's not much you can do with that. So our hope is that 256 we can write in terms of 2. That is 2 to the 8. All right. It's not quite that easy to look at 256 and immediately think it's 2 to the 8, but we know we're trying to match up to be 2, so you can kind of work from there. So now that we have 2 and 2, we can set our exponents equal to each other. And so notice we have an x squared, so this is a quadratic, so we have to solve it like a normal quadratic. We do that by bringing everything over to one side, so subtract the 8 over, and we're left, we have to, let's see, factor. We'll get 2 possible answers. So 8 is 4 times 2. It looks like we can get x equals -4 and 2. 2 possible answers.